Hey guys, starting to look at some of the questions you guys are having over the review here for 5.5, the quiz over 5.5 and 5.6. And we're looking at that third question, and I'm going to do it here on this paper rather than on my board behind me because I am going to make use of the graphing calculator here. Remember, you will have the use of the graphing calculator. I suggest using your graphing calculator to look at these, although, and we'll see, this is a good question. I'm glad you guys asked about this one. You will need tools other than your graphing calculator. So we were asked to find the zeros of this thing. All right. So again, the first thing I want to do is find that P over Q list. All right. Remember, P are all your factors of -4. So that could be positive or -1, positive or -2, and positive or -4. All right. Now, normally I'd make my Q list here, but I can see Q, my leading coefficient is 1. So all my P over Q list is just going to be all this over 1, which is really just this list. All right. So here are all my possibilities. Now, a thing to keep in mind, you're asked to find all the roots of this, and this thing, because it's a fourth degree polynomial, is going to have 4 roots. All right. Now, those might include double roots. They might include imaginary roots. We're just asked to find all the roots, but we should get 4 answers here. So the first thing I want to find are all the rational roots, all the roots that can be written as fractions, and I know there could be all 4 of them, but I know if they exist, they're in this list somewhere, either positive or -1, positive or -2, or positive or -4. So what I'm going to do is graph this. All right. So I've got that filled in here. And again, I remember I always do zoom 6 zoom 6 to get that standard window there from -10 to 10. And here's what I get. And so it looks like this thing has 2 real roots, and then it means the other 2 roots must be must be imaginary, because this only hits the x-axis twice. All right. So now those real roots, let's see if they're rational roots, because again, they could be real and not be rational. These roots could involve, the square root of -2 or square root of 2 or something like that. So, but it does appear that this thing goes through the x-axis at 2 and -2. And that would make sense because that's in our list here. All right. So let's just check those. All right. So I'm going to do second trace, or I'm going to do my calculate menu here. And that first choice is value. And I want to see where this thing is when x equals -2. And it is at 0. So that's one of the zeros. And I'm also going to check +2. So again, I do second trace again. I want to find the value at x equals +2. And that also gives me an answer of 0. All right. So we've got 2 of the zeros. 2 of the zeros are -2 and +2. Now those are my only 2 real roots. The other 2 roots must be imaginary. And to do that, to find those, I'm going to use synthetic division, first by -2 and then by 2. And again, the thing that you really need to be careful of, the thing that always seems to trip us up here, are those powers of x's that we've skipped. So in other words, I don't see an x to the third, so I'm going to have to fill in a 0 there. And I also don't see an x to the first, so I'm going to have to fill a 0 in there. All right. So let me go ahead and do synthetic division, again, just with my coefficients. So 1, 0, -3, 0, and -4. And again, the order really doesn't matter, but I'm going to do them in the order that we found them. All right. So the first thing I'm going to do is divide this by -2. Again, remember, this is all add and multiply. So I add and then I multiply. 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 And I add. All right. This gave me a remainder of 0, which is good because we already saw that this gives us an answer of 0. And now I'm going to divide that thing by my other root that I saw from the graph. I'm going to divide this thing by 2. So I add and then I multiply. I add and then I multiply. I add and then I multiply, and then I add. And remember, this was the remainder. That really wasn't part of it, so I don't need to worry about that second time. All right, and again, this gave me a remainder of 0, which is good because I know it also gives me a value of 0, so that just kind of justifies that remainder theorem. All right, so now so we found 2 of the roots. We got these 2 rational roots. How does this help us? Remember, if this is an x to the fourth, this is an x to the fourth polynomial or a fourth degree polynomial. This one is a third degree. This one is a quadratic, all right? So I can rewrite this thing as 1x squared plus 0x if you want, plus 1. And I want to see where that thing equals 0. And now at this point, since you've got it down to a quadratic, you can, now this thing is not factorable. We already saw it's going to have imaginary roots. You can fill, here's A, there's B, there's C. Fill those in the quadratic formula. That should give you the same answer that we're about to get. But here's what I like to do. Since I don't see an x term, I can just use square roots. I can use, inverse operations to get x by itself. All right. So again, if you want to do the quadratic formula, use a equals 1, b equals 0, and c equals 1, and plug those in the quadratic formula. You should get the same answer we're about to get. I'm just going to use inverse operations to get x by itself. So I'm going to do the opposite and do it to both sides. I'm going to start off subtracting 1, and that gives me x squared, or it was 1x squared. I'm just going to write that as x squared. X squared equals negative 1. And now to get x by itself, I do the square root of both sides. And anytime I do the square root, I always get that plus or minus. And then the square root of negative 1 is I. So there are my other two roots. All right, so the four roots of this thing are negative 2, positive 2. We got that from the graph. And then by solving this quadratic, the other two roots are positive I and negative I. All right, again, same answer you would have gotten if you would have done the quadratic formula. All right, okay, so this was number 3 on that review. I'll just write them all here in one spot. So the four roots of this polynomial are negative 2, positive 2, I, and negative I. Graph it, come up with that P over Q list, and hopefully find some rational roots, and then use synthetic division to get it down to a quadratic, because once you got it to a quadratic, we've got several different methods to solve that. All right, hope this helped. Let me know if you have any other questions. We'll talk to you later. Take care.